Hello everyone. So let me show you here on how are we going to solve for the vectors using the component method. So for the first set of given, we have here 12 meters 30 degrees north of east, and then we have 17 meters directed north. Now, paano natin makukuha yung resultant vector using these two given? So everybody, please take a look on the screen because I'm going to plot the two vectors in our Cartesian plane. So the first thing that we need to do, of course, is to write here our x and y axis. So this is for the x-axis, and this is for the y-axis. Okay, let us plot our vector A. So for the vector A, I will be using here the green pen to represent our given vectors. So 30 degrees, it's here 30 degrees. So assuming lang na this is 12 meters. Ayan, 12 meters. Vector A is equal to 12 meters. And then here is our 30 degrees. Okay, next, let us use the head to tail method. Head to tail method. Okay, so for the second vector, it is 17 meters directed north. So let's say this is 17 meters. Okay, 17 meters. And here it is for our resultant vector. So I'll be using here red pen for the resultant vector. Okay, so vector B, 17 meters directed north. And then for our resultant vector, I will be using d sub r here since we're dealing with our displacement. So we will be looking for our resultant vector later. But how are we going to do that? Let us look first for the x and y component of vector A and vector B. So let me write here a small table for our x and y component. Summation of d sub x and here summation of d sub y. Okay, so let us solve for the x and y component. So in getting for the x component, we will be using our d's cosine theta, and in looking for the y component, we'll be using our d sine theta. So let us go first with the vector A. So A sub x, we have d cosine theta is equal to question mark muna. So A sub x, the magnitude is 12 cosine. Take note that our angle here is located on the first quadrant. Again, our reference angle is on the first quadrant, so substitute lang 30. So let me use the calculator. 12 cosine. Cosine 30, that is equal to 10.39 meters. So A sub y, we have d sine theta equals question mark. So a sub y is equal to 12 sine 30. Same angle will be used, huh? Okay, so let me just change here cosine to sine, and that's equal to 6 meters. So for our x and y, here it is. So for the x component for a, we have 10.39. For the y, we have 6 meters. Now let's go to our vector b. For vector b, we have b sub x equals to d cosine theta. So b sub x here, we have 17 cosine. So 17 meters cosine. So this is directed north. We have 90 degrees. So cosine 90 is equal to 0. So 17 times 0, that is 0. So b sub y, we have d sine theta. So 17 sine 90 there. Sine 90 is equal to 1 times 17. We have 17 meters. So for our x and y component for vector b, we have 0 for x and 17 meters for y. After that, let us add the values inside the table. So 10.39 plus 0, that is 10.39 meters. And then 6 plus 17, we have 23 meters. Now that we got the values for the summation of x and y, so these values will be substituted in our Pythagorean theorem. And by the way, where is this summation of d sub x kag summation of d sub y? It's right here. So it's just right here. This is for our summation of d sub y, and that is 23 meters. And for the x, it's right here. So summation of d sub x, that's 10.39 meters. By the way, if you are going to take a look here, um, the y component is positive, so meaning it should be directed to the positive y. So the x component is positive as well, so it should be directed to the positive x. So this is for the summation of y and summation of x. Now let us solve for our magnitude. So to solve for the magnitude, we will be using here d sub r is equal to d sub x squared plus summation of d sub y squared. Just simply substitute the values. Substitute nyo lang. So we have 10.39 meters squared plus 23 meter squared. Okay, let us use our calculators. 10.39 squared, that is equal to 107.95. So we'll just use two decimal places. 107.95 meters squared plus 23 squared, that is equal to 529 meter squared. Let us add the two values. 107.95 plus 529, that's equal to 600. Square root of 636.95 meter squared. So let us square root the answer. Square root the answer. That is equal to 25.24. 25.24. And after that, let's cancel the square here and the square root. We have meters. So 25.24 meters is our resultant magnitude for our resultant vector. So this is 25.24 meters. Now it's time for us to look for our angle or the direction of our resultant vector. By the way, our final angle should be following the counterclockwise direction. So therefore, ito yung angle na hahanapin natin. And in order for us to do that, we will be using our tangent function. So tangent theta is equal to opposite over adjacent equal to y over x. Okay, sino ba si y? Sino ba si x? So we have here tangent theta is equal to sino ba si y? That is summation of d sub y over summation of d sub x. So substitute the values. I'm going to do it directly. We have here theta is equal to transpose the tangent on the other side. We have tangent -1 times 23 meters over 10.39 meters. Cancel here, cancel the units. So in our calculators, let us use shift tangent. We have 23 over 10.39 meters. And that is equal to 0. Oh, sorry, it should be arctangent. Arctangent siya dapat. So shift 10. Okay, that is 65.69. Our angle here is 65.69 degrees. So this is now our reference angle. Take note that our angle is, by the way, our resultant rather, is located on the first quadrant and our reference angle is 65.69. Now let us take a look here on the board. So if your angle or reference angle is located on the first quadrant, that will be equal na to your final angle. So in writing our final answer, it should be like this. D sub r is equal to 25.24 meters, comma, 65.69 degrees. And this is now our final answer. So I hope na nagets na siya.